Hello, hello. This is Mrs. Hickman, and today we are going to be going over trig derivatives. So let's go over them. So please remember, this d over dx just means find the derivative of the trig function, and when you do the equal sign, it's going to give you the trig function. So here, the derivative of sine x is cosine x. The derivative of cosine x is negative sine x. The derivative of tangent x equals secant squared x. The derivative of secant x is secant x tangent x. The derivative of cotangent x is negative cosecant squared x. And the derivative of cosecant x is negative cosecant x cotangent x. Okay, so if you're getting concerned about remembering these, just remember the tangent and the cotangent, which are reciprocals of each other. This one will have secant squared x, and this will just be negative cosecant squared. And then you have the reciprocals of secant x and cosecant x, okay? So the reciprocal of cosine x is secant x, so that's just secant x tangent x. So then this is going to be cosecant x cotangent x, okay? Here's a little review of derivative rules. Last time I went over derivatives, I did not do it this way. The way I did it was you have d over dx. You can do it this way. I just use P and R for product rule if it makes it easier for you. But last time I did d over dx of fg is going to be f prime of g plus g prime of f, okay? Or you could say r prime of p. This one is usually smaller than that one. That's why I like it on the left-hand side. Or you could say you're alternating derivatives. And then quotient rule. So quotient rule. So there's the top. There's the bottom. In the other video, I did it like this. D over dx of f over g equals f prime g minus g prime f over g squared. A lot of books do it different. Some books will be using u's and v's. We will be using a lot of u's and v's later on. So it can get confusing with the different variables. That's why this year I want to try it with f's and g's. And so if anybody else is watching this video, they can follow along too. Okay? So we're going to look at our first one. So this is the product rule because we have one function multiplied by the other function. So f is x squared. G is going to be tangent of x. So then f prime is 2x and g prime is secant squared x. So find dy over dx, so that just means find the derivative when y equals x squared tangent x. So y prime is going to be f prime of g plus g prime f. So you can do g prime f, you get secant squared x times x squared. I like the variable to be first, so I'm just going to do x squared secant squared x. Okay? And if you want to factor the x out, you can. It's not really going to do anything. There's not going to be any identities hiding there. Unless you want to make this 1 plus tangent squared x. But there's no like terms. So, there you go. Okay, let's do this one. So this is going to be a quotient rule. So f is sine x. So then g prime is going to be cosine x. F prime. And then over here we have g is going to equal 1 plus cosine x. So remember the derivative of 1 is just a 0. Horizontal lines have a slope of 0. So the derivative of cosine x is negative sine x. Okay. So again, this is saying find the derivative with respect to y when y equals this. So y prime is going to be cosine x times 1 plus cosine x minus g prime f, so that's going to give me negative sine x times sine x is sine squared x over g squared. So you get cosine x, and distributing the cosine, so cosine x times 1 is cosine x. Cosine x times cosine x is cosine squared x, just like x times x is x squared, plus sine squared x. Okay, and I hope you see this. This is the identity. Remember the identity, sine squared x plus cosine squared x equals 1. So that's a trig identity. Whoopsie. So this is going to turn into a 1. So that's going to be cosine x plus 1 over 1 plus cosine x squared. There's one more thing to this derivative. We have cosine x plus 1. That's the same thing as saying 1 plus cosine x. So I'm just going to use a commutative property of addition. Okay, so just like 1 over x and 1 over x squared, this is going to be canceled out. So you have 1 over 2 is 1. So you have 1 over 1 plus cosine of x. Okay, and that's how you do that. So far your homework is 1 to 9 odd. We're just going to do the back of this and then we'll be done for tonight's session. Okay, I hope you remember your unit circle because it is back again. Remember when I said it was important to learn? Well, it's still important to learn because as you can see, 0 to 2 pi. Okay, so this is like solving. So horizontal tangent, if you can remember, that's when the derivative equals 0. So this can be y prime equals 0. Okay, that's all it means. Because if you're looking at a horizontal line like this, okay, if you were doing a tangent point here, you would have your tangent line would be a horizontal line. So your slope of a horizontal line is 0. So y prime, or 0, is going to be square root of 3 plus cosine of x is negative sine x, so that's going to be minus 2 sine of x. Okay, isolate your trig function. So you're going to subtract square root of 3 on both sides. Okay, divide by negative 2. Okay, so now you have to remember where sine x is equal to square root of 3 over 2. So square root of 3 over 2 is an exact value on unit circle. I hope you know that. Okay, and you're looking to see where sine is positive. Well, sine is positive in quadrant 1 and in quadrant 2. Okay, so sine, so where sine is square root of 3 over 2, that's going to be at 60-degree angles. Okay, if you can remember, I'll just do it really quickly over here. Okay, remember? So everything's over 2. Oops, sorry. Okay, so this is going to be square root of 3, square root of 2, square root of 1. Square root of 1 is 1. Then you go back the other way, so you have square root of 3, square root of 2, and 1. Okay, so sine is square root of 3 over 2 here, and it's symmetric with this angle over here. So this angle is pi over 3, and this angle is 2 pi over 3. If you're wondering how I got these angles, please see unit circle. So your x is going to be pi over 3 and 2 pi over 3. That is your answer. Okay, so that is our angles between 0 and 2 pi. Okay, don't forget to do this one for homework. So this is me writing it down. Do that for homework. Next, find the equation for the line that are tangent and normal to y equals secant x at x equals pi over 4. And we're going to round to decimal places. Okay. So first we need to find the slope. So we have y equals secant x. So y prime, which is going to be the slope. Remember, the derivative is the slope of the function. Is going to be secant x tangent x. Okay, we have our x at pi over 2, so where you see x, you're going to put pi over 2. Okay, so y prime pi over 4 is going to be secant of pi over 4. Tangent of pi over 4. Now, if you don't know secant of pi over 4, just go up here. The opposite of secant is cosine. So to find this, you're going to do 2 over square root of 2. So we'll just do that here. So 2 over square root of 2. Rationalize the denominator. So you're going to get 2 square root of 2 over 2. So that's just going to be square root of 2. So secant of pi over 4 is square root of 2. Okay, tangent of pi over 4. So that's the numerator of sine. So here's pi over 4 right here. So tangent is the numerator of sine of the numerator of cosine. So square root of 2 divided by square root of 2 is 1. So your slope is square root of 2. Now you need to find your point. Your x value is pi over 4, so your y value is going to be your original function, and you're going to put your x value in. So you have pi over 4 and secant pi over 4, because that's what you started with. And we already know what secant pi over 4 is. It's square root of 2. Okay, not done. We need our tangent and normal line, so I'm just going to do the tangent up here. Slope is square root of 2, so y equals square root of 2 x minus pi over 4 plus square root of 2. Okay, so you can either put in decimal notation or just write it like this. Your book will probably do that. So square root of 2 x minus pi over 4, well, square root of 2 pi over 4. This is why I said to use decimals, plus square root of 2. But I don't feel like getting my calculator out, so. Decimal form is going to be 1.414x plus 0.629. That's the tangent line. The normal line your slope is going to be negative 1 over 1.414. So your slope is going to be negative 707. Negative 0.707. And you're still working with the same points, which is going to be pi over 4. Pi over 4 is actually 0.785. And square root of 2 is 1.414. Again, you just use your calculator. I'm just putting this into decimals. Okay. So to find a slope, it's going to be y equals negative 0.707 x minus 0.785 plus 1.414. So 1.414. So your normal line is going to be negative 0.707 x plus 1.969. Okay, last one. Okay, we're going to find the second derivative of this function of pi over 6. Don't forget that homework is going to be attached to this one right here. So we have f of x is cosecant of x. F prime of x is going to be negative cosecant x cotangent x. F double prime, you're going to need to use the product rule. So you can either leave that negative out in front or put it in with your first derivative, which is what I'm going to do. It just makes it easier. Negative cosecant x. So f prime is going to be negative times negative cosecant x cotangent x. Remember, negatives still acts like a constant. So your f prime is going to be cosecant x cotangent x. Over here you have g, which is going to be cotangent of x. G prime is cosecant squared, negative cosecant squared x. Okay, so let's go ahead and put that in our second derivative. I'm going to make more room. So f double prime, product rule is f prime of g, so cosine x cotangent x times cotangent x. So you get cosecant x cotangent x cotangent x plus g prime f, which is going to be negative cosecant squared x times negative cosecant x. Simplifying it out, you're going to get cosecant x cotangent squared x plus cosecant cubed x. Please remember, with these squares, you're essentially saying the same thing. Cotangent of x squared, cosecant of x cubed. So when you find the exact value, you're going to be cubing them. So we're going to do f prime, f double prime of pi over 6. Cosecant is 1 over sine. Pi over 6 is here, so this is going to be a little bit easier. So cosecant of pi over 6 is just a reciprocal of sine. So sine of pi over 6 is 1/2. So cosecant of pi over 6 is going to be 2. And then cotangent is going to be, you could do x over y or just do the opposite of tangent. Cotangent of pi over 6 is going to be square root of 3. So that's just a numerator of x over numerator of y. It's the opposite of tangent. Tangent is numerator of y over numerator of x. So tangent is reciprocal. So cotangent of pi over 6 is going to be square root of 3. And I don't want to see decimals. It's a unit circle. You had to learn it for a reason, so use it. Okay. All right, so now we got cosecant. Yes. Also note, if I see decimals on the SIR quiz, there will be points marked off, like you won't get the answer. So for those of you who I am not your teacher, you need to know this. It is important. It will help you later, I promise. Okay. Cosecant pi over 6, cotangent squared of pi over 6, plus cosecant cubed pi over 6. Cosecant pi over 6 is 2. Cotangent is square root of 3. Squared, the square comes from here. And then cosecant is going to be 2 cubed. So you're going to have 2 times 3 plus 8, which is 6 plus 8, which is 14. However, I'm missing a negative somewhere. Last year I got negative 14. Okay, well, if you end up getting negative 14, I just messed up with the negative somewhere around here. I can't pause the video and go check it out, but I'll show this one up here so you can see it. So you can pause your video and see if you can see where I made a mistake. Okay. Okay, well, that's the one I did last year. I got negative 14. This year I got 14. Please don't forget to do this problem in your homework for the class I have now. And y'all have a good night.